Okay, we have two 182Ts. Okay, these are both G1000 airplanes. One 941 Charlie Pop is a 2007 model. It's got a first generation G1000, and it has vacuum backup in case of total electrical failure. So it has attitude, altimeter, and airspeed steam gauges. And at any rate, in order to fly the G1000 airplanes, you will have to have a G1000 qualification, and that's some more training that you would have to take on the system. You can get onboarding flights with that too, or transition flights to that. So anyway, the new airplane, 184 Charlie Alpha, this is a 2024 model. It has what's known as a G1000 NXI and electronic stability protection. Electronic stability protection is something that if you try to bank beyond, say, 45 degrees or so, it starts pushing back on you. And it will actually take the airplane away from you if you hold it, if you try to do something, excessive too long. It'll switch into a level mode on the autopilot. Anyway, that can be turned off for doing steep turns, but it's if you let's say you get into a high speed dead man's spiral or graveyard spiral, it'll level the airplane. Yeah, it'll do it all on its own. It has low speed protection. It has high speed protection. However, this airplane's got a GI 275 instrument in it. That's another Garmin instrument, and this one has all the backup instruments that you need. It's got the attitude, it's got the HSI, it's got airspeed and altimeter, and it also has its own battery. 184 Charlie Alpha does not have a vacuum system. Okay. So both of these airplanes were anything after about 1990, I think it was 7 or give or take 98, was when Cessna restarted making airplanes. They had shut down making reciprocating engines in around 1984. And then they restarted. And at that point, you wound up with 13. No, they stopped. They stopped production in the 80s because of liability problems. So anyway, the new airplanes have got a couple of problems. They got 13 fuel drains to hit when you do your pre-flight. You got 5 in each wing and 3 underneath the fuselage. Even though our 182s carry 92 gallons or 87 usable, we only fuel it to 55 gallons because they are so much heavier than the old airplanes. Anybody who has flown an old 182 will find that the empty weight of the new 182s is significantly higher. So we restrict 55 gallons because, if you want to put 3 or 4 occupants in the airplane, there's no room for the extras, for the extra fuel. The fuel selector has both left, right, and off positions, like most Cessnas. The selector is going to be pushed down to change positions, and the fuel pump is only needed to prime for starting. You can also use it. I don't know if anybody here has ever run into it, but if you get a hot day with hot fuel and you start a pretty significant climb, you can get some fuel vaporization, and you'll see your fuel flow start to wander a little bit. And generally what will happen is the CHTs will start going up, and At that point, you can turn a fuel pump on to kind of stabilize that fuel vaporization. And if you do that, you may have to re-lean the airplane a little bit because your fuel is liable to get a little too rich. So again, we're just hitting the highlights. And this is a big one. The 182T, the new ones, have a maximum landing weight of 2,950 pounds. That's lower than its gross weight. They allow you to load up to 3,100 pounds for takeoff. However, that's 150 pounds, okay? That's 25 gallons of gas. So what that means is if you take off at full gross, you're going to have to burn 25 gallons of gas to get back down to 2,950 before you can land legally, okay? This is not something that happened with the old 182s. So suppose you're going to carry 3 or 4 occupants and you're going to drop one off after an hour and the remaining are continuing on. You can still be above maximum landing weight after an hour. You may have to reduce fuel and take off at maximum landing weight and fuel at your first stop. And that's why we only fuel them to 55 gallons, okay? You can land in an emergency situation. However, the aircraft must be grounded until an overweight landing inspection is made by an A&P, and you have to notify the maintenance officer. Not a good thing to do. If you look at the old 182s, they were 2,950 full gross and 2,950 and landing weight, the same thing. But they were a lot lighter than these new airplanes. So that's how Cessna increased the weight carrying capacity for the new 182s was they gave it a maximum weight and then a maximum landing weight. So anyway, the performance charts are in section 5, and you've seen them. They give you your normal short field takeoff and landing at various weights and temperatures and altitudes. They also provide time and distance and fuel to climb, as well as cruise performance at different altitudes. And they also have a range profile, but I think that uses the FAA 45-minute reserve, where we require a 1-hour reserve. So these performance charts are found in section 5. And let's plan a trip, okay? You got a 182T. You're going to plan a trip in it from Trenton Robbinsville to Coatesville to Syracuse. You're going to leave Trenton Robbinsville with 3 occupants. You're going to drop one off at Coatesville, and you're going to continue with 2 to Syracuse. 185-pound pilot, 190 and 220 for the passengers, along with 40 pounds in baggage and 30 pounds in the rear baggage. And you're taking off with 55 gallons of fuel on board. The 190-pound passenger will get off at Coatesville. But a fuel burn from Coatesville or from Robbinsville to Coatesville is going to be about maybe 8 gallons. Can you land immediately upon arrival? Well, take a look at the weight and balances. You're taking off your 3,025 pounds, which is well under your maximum weight. But when you're landing, you're at 2,984. Okay? So you're above maximum landing weight. You got to burn off about 30 minutes of fuel to reduce your initial fuel load to 49 gallons. So this is the kind of what you got to be careful of with the 182. 182s, both of them. All right. So let's say we landed at maximum landing weight at Coatesville. Now it's 188 miles from Coatesville to Syracuse. And let's say the winds are light and variable at 9,000 feet. The weather's VFR. So we're going to go GPS direct to make this whole thing simple. All right. We landed with 41 gallons of fuel, which put us at maximum landing weight. So we look at section 5. We have time, fuel, and distance to climb at 3,100 pounds. Okay, so we're a little lighter than that, but they're going to give you weights at 3,100 and a bunch of different ones, but you're safe using the 3,100. Okay, gives you the conditions for this. Flaps up, 2,400 RPM, full throttle and mixture set to maximum power fuel flow. Placard. Valve flaps open, standard temperature. Okay, so we're using the standard international atmosphere temperature, ISA temperature. So you look down here and you go through here and you're going to go up to 9,000. Let's say you're going to go to 10,000 feet. Okay. And it says that it's going to be about 18 minutes. I mean, if you want, you can average these out. And it's going to be 6.3 gallons of fuel because it says add 1.7 for start, taxi, and takeoff. Okay. So 4.6 gallons plus 1.7. So with that fuel burn at 6.3 gallons, 18 minutes, we will be 31 miles away from Coatesville, and we'll be at 9,500 feet. And they also give you stuff here about increased time and distance by 10% for each 10 degrees C above a standard temperature. Right? So this is why you have a calculator. All right. So now we're up at 9,500 feet. And we need 12.5 for minimum reserve. So we got 22.7 gallons available for cruise and descent. Great. So what we need to select from the next chart, which is cruise performance, pressure altitude 10,000 feet. And we're using the ISA atmosphere here, the standard temperature, which would be -5 C. Okay. So we have to go 157 miles on less than 22.7 gallons. You're only going to get about 20 inches of full throttle at 9,500 feet. 20 inches manifold pressure at full throttle. So we look over here, we look at 20 inches in 2,000, and that gives us 58% power, I think. 58 to 60% power, 127 knots, and 10.4 gallons per hour. Let's say we want to go a little faster. So instead of 2,000 RPM, we're going to run 2,400 RPM. Okay. So that's given us more like 68% power. In this case, I get 72%, but speed's 139 knots, and we're doing 12.1 gallons an hour. So either setting will get you there with your reserve. And if you work through the arithmetic, you'll save 6.6 minutes at the expense of 0.8 of a gallon with the higher power setting. And generally speaking, these things are going to be pretty close. Whether you're going to be right on the money, they'll be close enough. So this is the exercise that you'd have to do if you're going to use the airplane to go, on a trip somewhere. Now, for descending, there's a thing called a rule of 3. If you take your cruise altitude minus your pattern altitude in thousands, multiply it by 3, gives you an estimate about how far out to start the descent. In this case, Syracuse pattern would be about 1.5, 1,500 feet. We're at 9,500. That's 8,000 times 3. So about 24 nautical miles out, we should be starting down. Okay. And, you can fudge that one way or another depending on how you feel about your descent rate. So let's go to the 206. Okay. Now, we won't go through that exercise on the 206 because it's essentially the same thing. You look in the book and pick the numbers, and that's it. So 50 Mike Bravo is a 1980s model. Okay, and what we have in that is a G500 primary flight display, which is the display for the GTN 650 Navigator. It also has an S-Tech autopilot with GPS steering and altitude hold, but there's no preset or glide slope capability with the autopilot. So it won't follow a glide slope, and you can't preset an altitude. You push a button and it'll hold that altitude, but that's it. And the engine monitor is an electronic instruments device. This has all vacuum backup using steam gauges. So it's got a gyro, it's got altimeter, airspeed. Now, oops. What am I doing? My fingers are not, here we go. Okay, the fuel system in the airplane is a little unique, okay, as far as anything we have. You really have to study the POH section 722 to 26, pages 722 to 726 for complete info. The fuel is stored in 2 tanks. It's got 1 in each wing, 92 gallons, 88 usable. It's got 5 fuel drains. It's only got 1 in each wing, and it's got a pull drain under the left side oil door. It also has 2 reservoir tanks under the belly that have drains. The POH does say drain the reservoirs only if water is found in any of the other 3. That don't mean you can't drain them, but it's just that they say that you're only going to find water there if you found water in any of the other 3. The fuel selector does not have a both position, left, right, and off. So if you're flying the 206, you got to remember to switch the tanks every 30 to 60 minutes. The GTN 650 and the engine monitor have timers that can be set as alarms. The other thing about this airplane, do not use the fuel pump for takeoff or landing. Okay, it's only start. If the aux pump's on while the engine-driven pump is operating correctly, the mixture can be rich enough. Remember I said too rich a mixture and it won't run? Here you go. The mixture will be rich enough to cause a loss of power, possible, depending on where you got the throttle and mixture set. Again, the pump can be used if you start getting a fluctuating fuel pump or fuel flow on climbing on hot days. But again, you turn the pump on and you may have to re-lean it to compensate for that a little bit. The fuel pump switch on that airplane has a red side that's got a red button that's spring-loaded, and it's got a yellow button. They're right next to each other. And the yellow button, as you push it on, you got to push it off. Okay, that's used for starting. All right, turn it on, turn it off. Once the engine started, first off, the switch should be off while the engine is started, and after the engine is started, it should absolutely be off. Okay. The way you operate this thing, in case you have an engine-driven pump failure, if your takeoff or climb power, you push the red side and hold it, okay, until you get up clear. Level off, let go of the red side. When you push the red side, you turn the yellow side of it on. So the yellow side will continue to keep you running while you try to come back to the field. And the other thing it will do is if you pull the power all the way back, it'll slow down even more, so it won't flood the engine as you come in for the final approach. But again, if you read 722 to 726, you will find that information. Okay, the airplane has 6 seats. The 2 back seats are pretty small. It has a passenger door on the left side. There is no passenger door on the right side, but there is a utility door behind the front seats on the right-hand side. Okay. And they allow, you can remove 5 seats for accommodating cargo in it. The engine is a Continental 300 horsepower at 2850 RPM. 5-minute limit on that power setting. 285 horsepower at 2700 RPM, continuous. Okay. What happened there is that they wanted 300 horsepower, but the biggest Continental at the time was the IO 520 285 at 2700 horsepower, or 2700 RPM. Remember I said you increase RPM, you increase horsepower? So what they did was they spun the engine up another 150 RPM and got another 15 horsepower. The only problem with that is that makes the engine very, very loud because the prop tips start to approach the speed of sound, and they are annoying to people around airports. So, also the start procedure is different from the Lycoming engines in the 182s. So, what you want to do is always use the checklist on either airplane. Gross weight and landing weight's the same, 3,600 pounds. Okay, so you don't have to worry about the maximum landing weight. Now, these utility doors are double doors, okay? And flaps will hit the utility door, if the front utility door, if you try to open it with the flaps down. So there is a switch on the door that prevents the flaps from operating if the doors are not closed and latched. Inside, there's a placard that shows how to open the door in an emergency if the flaps are open. You can't get the whole door open, but you can get the rear part of it open enough to be able to get out. The other thing that 206 has is 40 degrees flaps, and they get a lot of drag, and they will allow very steep approaches. So if you do use the full 40, I mean, you don't have to use the full 40. I mean, you can use 30. But if you do use the full 40 and you need to do a rejected landing and you jam the power in, the pitch up and left yaw can be real impressive. It's a perfect full spin setup. Add power smoothly. Forward elevator, keep the pitch around 7 degrees while manually trimming the nose down. Retract flaps to 20 and enough right rudder to remain coordinated. On takeoff, to get 300 horsepower, you use 2850 RPM to get 300 horsepower. And I like maybe about 300 feet below pattern altitude, everything's running good. But 300 feet below pattern altitude, I'll just dial the prop back to 2700. Okay. It cuts the noise down, and again, it helps with the neighbors. So you don't have to move the manifold pressure at that point. You just dial it back to 2700 and leave the throttle full. The engine's rated for continuous power at that setting. And as far as using the avionics, that's something that'll come up with your flight during the flight training. And again, your flight planning is going to be the same. POH for 206 is written by the same people that wrote the POH for 182, and all the stuff is in there. It's just that you have to, you you had to go through it. You had to do some flight planning. So here's some of these are just some hints from me, I guess. Let's say you're at cruise, you're cruising at altitude. You got the airplane trimmed, all right? Generally, if you reduce the manifold pressure about 1 inch for each 100 feet a minute, the rate of descent you want, without changing the trim setting, the airplane will pretty well do it. You want to come down 500 feet a minute, back off 5 inches. Okay. Don't forget that rise in manifold as you come down. Okay. Rise in manifold pressure. Don't forget to be backing off about 1 inch every 1,000 feet. Clean the mixture according to POH. And, I know we won't run into it around here that much, but if you happen to be at a high density altitude airport, that's how you get your best performance. Probably around 17 to 18 inches of manifold pressure will work to control the speed when entering downwind at lower altitudes, maybe 16 inches. Okay. But what you want to do if you're flying these airplanes is, the manifold pressure, RPM, and pitch that gives the desired speed for cruise, for descent, and approach level and descent. Okay, so you get into approach mode. If it's, it's a step down in your level, know the pitch, attitude, manifold pressure, and RPM that will hold the speed that you want. And also for the descent. That way you set the controls, the plane's going to do the rest. Pitch and power equals performance. If the POH allows it, there's no problem with Oversquare, which people refer to as, I run 25 squared or 24 squared. There's no problem with Oversquare manifold pressure higher than RPM if the POH allows it. Okay. Generally, you want to reduce manifold pressure before RPM, because what's going to happen is when you reduce the RPM, the manifold pressure is going to bump up maybe about 1/2 inch to 1 inch when you pull the RPM back. The other thing, in the checklist, you go to full increase RPM as you approach landing. Don't do that on downwind, okay? Wait until you're maybe on base and the airplane's manifold pressure and the speed are low enough that the prop is already on the low pitch stop, okay, before you advance the control full in when landing. It prevents the RPM from surging way up, okay? If you do that and you're, let's say you're on the downwind, and you still got some power on and you're still going relatively quick, you shove the prop in, the RPM is just going to surge right up to the maximum, and it's going to make a lot of noise, okay? And besides that, the engines really don't like that stuff. So wait until your propellers on the low pitch stop, and that'll be, you got the power held back, and or you got the manifold pressure back, and your speed is down. Then you can push the prop up. It's probably already against the low RPM stop. So, and be mindful of the engine temps. Maintain your CHT. Excuse me. Try to keep it less than 400 degrees when you're in cruise and incline. Increase the fuel flow if necessary. A richer mixture cools CHTs off. High power, low speed, cowl flaps open. Okay. And use 90 plus knots for cruise climbs, because that way you'll get more cooling airflow. Okay. You have another quiz to take. And that'll be it after that.